Hello everyone. Today let's discuss about the expression for Gauss law and its proof. So the statement of Gauss law is total flux of the electric field over a closed surface is equivalent to 1 by epsilon 0 times the total charge enclosed by the surface. That is, if we consider a closed surface, the flux present in the closed surface can be found by the reciprocal of permittivity of free space. That term will be multiplied by the charge present in that closed surface. So this is said to be Gauss law. So that relation can be written as phi is equal to q by epsilon naught. So in the next step, I am going to say about the proof of it. For that, I have given the figure. In that figure, I have taken a closed surface. Within that closed surface, AB is the portion said to be Gaussian surface. It is an elementary surface. There is a point P in which at that point P, the electric field intensity of this particular surface exists. So that is denoted as P. And ds is the elementary surface. Next, n is said to be it is a normal line drawn from the point P, and theta is said to be the angle that exists between electric field and the normal, and r is the distance between the origin O and point P. Then in that origin O, a positive charge exists, which is denoted as plus q. Then d omega is the solid angle obtained by this Gaussian surface. So I have explained about the figure. Next, in equation 1, it is given electric field intensity which exists at the point P. So that is written as 1 by 4 pi epsilon naught into q by r square. Next step, flux over the elementary surface area ds is written as d phi is equal to E dot ds. D phi is the flux present in that Gaussian surface. So dot product E dot ds can be written as E dot ds E ds cos theta. That is equation 3. So in that equation 3, I am going to substitute equation 1. So it becomes d phi is equal to q by 4 pi epsilon naught r square into ds cos theta. Whereas in the next step, this ds cos theta divided by r square is going to be written as solid angle. Ds cos theta divided by r square is d omega. So in equation 5, I have wrote it as d phi is equal to q by 4 pi epsilon naught into d omega. So next, so far we have found the flux present in that Gaussian surface. In the next step, I am going to tell about the total flux. So total flux can be found by integrating that particular surface. So here phi can be found as phi is equal to integral of d phi. So already d phi is found out as q by 4 pi epsilon naught into d omega. So that is substituted here. So integral of q by 4 pi epsilon naught into d omega. Whereas q by 4 pi epsilon naught is a constant term. So I have taken it outside the integration part. So within that integration, there is only solid angle term, that is d omega. So integration of d omega is nothing but 4 pi. That value is 4 pi. So I have substituted in it in equation 6. So phi is equal to q by 4 pi epsilon naught into 4 pi. So 4 pi and 4 pi get cancelled. So remaining term is q by epsilon naught. That is the total flux enclosed within the surface. So phi is equal to q by epsilon naught. This flux can also be written as integral of E dot ds. So in the next step, I have wrote it as integral of E dot ds is equal to q by epsilon naught. So this is the famous Gauss law. As we have proved it, there are two more special cases in it. So first one is, in the Gauss law, we have so far considered that charge plus q is present within that Gaussian, that is closed surface. In a condition, if it lies outside that closed surface, means what happens is, this charge will not contribute anything to that particular closed surface. That is, q term will be equal to 0. Since q term will be equal to 0, automatically that integral of E dot ds is equal to 0. So that is said in case 1. And then case 2 is, so far we have considered only one charge, 1 point charge. If there are more number of charges existing in that surface, means we can sum up the all charges, that is q1 plus q2 plus q3 going on up to qn, whatever it be. So we can add up all those charges and it reflects in the total flux. So that is written as phi is equal to 1 by epsilon naught into q1 plus q2 plus q3 going on up to qn. So left hand side phi can also be written as integral of E dot ds. So that is given in the final step. So that's all about the Gauss law.